In this video we want to talk about profit, and in particular profit maximization. Profit is simply the difference between revenue and costs. So we may have issues in the definition of costs. For example, we have two types of costs: explicit costs, which are all the costs of running the business, the sort of costs that enter into the profit and loss account. We've also got implicit costs, which are the opportunity costs associated with running the business. These are the costs of the next best alternative foregone. And that's the subject matter of separate videos. But having said that, profit can be seen still as simply the difference between revenue and cost. So in terms of writing it as an equation, we could write it as profit is equal to total revenue minus total cost. TR minus TC, total revenue minus total cost, which is our profit expression. Now, sometimes instead of writing profit, the symbol we use is pi. Pi for profit, P for profit. So don't confuse it with pi in mathematics, which is the related to circle and has a value of 3.14159.265, etc. Pi here simply means profit. It's a shorthand way of writing profit. So profit is equal to total revenue minus total cost. Now, marginal revenue. Well, marginal revenue is the difference in total revenue divided by the difference in output. So when output changes by a small amount, what's the impact on total revenue? If output changes by 1 unit, what's the change in total revenue? And that change is the marginal revenue. Now if we set, in terms of calculus notation, let me just put the cursor onto the screen. Here we go. Here's marginal revenue, and here is the change in, this very small change in total revenue, very small change in quantity. So when we divide the change in total revenue by a change in quantity, a very small change in quantity, that's really what we call the calculus. That's the first differential of total revenue. And in calculus, we set that equal to 0 when we want to maximize a function. So in calculus, when we differentiate an expression and set it equal to 0, we're looking for it to be maximized or minimized, depends. But in this case, we're looking for it to maximize it. We want to maximize profits, not minimize profits. So that's the way we would write it. Obviously, to understand that fully, you should have some basic knowledge of the calculus. Now, what we could say, of course, is that the change in profit with respect to output is equal to 0. So it's the profits are maximized when we differentiate the profit function. Profits might be a function of or related to the level of output, for example. So if we differentiate it with respect to output, set it equal to 0, then profits are maximized. Clearly, you do need some knowledge of calculus to understand that completely. But what we do know is that profit is equal to total revenue minus total cost. So if we now use this expression here and differentiate all the way across, in other words, change the output by a very small amount, say here, and we do it all the way across. We change the total revenue by a small amount, change quantity by a small amount, change total cost by a small amount, change the quantity by a small amount. So all we're doing is we have a denominator which is dq, in other words a very small amount of q, and a numerator which is a change in, a very small change in profit is equal to a very small change in total revenue minus a very small change in costs. And putting it like that, it does make sense. So we set it equal to 0 for a maximum. If we go back to the original, there's our expression, that's what we've got. We set this equal to 0 for maximum profits. And this term here is just the marginal revenue. This one over here is just marginal cost. So what we've actually got is the change in profit with respect to output is equal to marginal revenue minus marginal cost, which is equal to 0 if it's maximized, if the profits are maximized. In other words, marginal revenue, take marginal cost to the right hand side, marginal revenue is equal to marginal cost for maximum profits. So there are two conditions for profit maximization. First of all, marginal revenue equals marginal cost. If that happens, profits will be maximized. Well, that's one of the conditions. The second condition must also be met. The second condition is that the marginal cost curve must be upward sloping. This is called a second order condition. I will not be proven here, but it must be remembered. The marginal cost must be upward sloping. If you do calculus, when you're calculating a maximum and you differentiate the function and set it equal to 0, you could actually be working out the minimum. So you have a second order condition which must be applied. The second order condition tells the person whether the figure calculated was a maximum or a minimum. Because you work out a minimum, maximize a minimum, you minimize costs in the same way as you would maximize costs. Marginal revenue equals marginal cost. So we need a second order condition. And the second order condition here is that the marginal cost curve must be upward sloping. As I said, I'm not going to prove it here, but it must be remembered. And it will crop up in other videos on this topic. This is just a general introductory topic, getting you started just to think about profit maximization. Let's look at this table, which may help. Here we have output, we have marginal costs, marginal revenue, marginal profits, and total profit. So let's look across the table. Let's say we have output of 1. Just here, output of 1. Marginal costs, let's say 5. Marginal revenue is 10. Marginal profit is 15. In other words, if you produce just one output, you get a profit of 15. So the total profit is 15. If you produce 2, marginal cost has gone up to 7. So the cost of the second unit is 7. Marginal revenue is 18. So the marginal profit is 11. 18 minus 7, which is 11. But now we've earned an extra 11 profit, so add that on to what we made before, the 15, giving us 26. So 15 plus 11, 26. If we have 3 units, the third unit has a cost of 10. That's the third unit. Not the second, not the next one, it's the third unit. We were able to work out the cost of the third unit, which is 10. That's the marginal cost. The marginal revenue, we'll say, is 16. So 16 minus 10 is 6, which is the marginal profit. Add the marginal profit for the third unit to that of the second, so overall profits are 32. And that's how the table is constructed. So maximum profit occurs somewhere between 3 and 4. If you look at the total profit, it goes 15, 26, 32, then 32 again, 25 and 8. So it goes up to 32. There are two number 32s. There are two at output level 3 and output level 4. The total profit is 32. And then the profit starts to decline afterwards. It could be the sales are falling off, the company's getting a bit too big, or costs are rising, or whatever. So maximum profit occurs somewhere between 3 and 4 units. Now, the solution, therefore, is that marginal revenue must equal marginal cost. And if you look at 4 here, marginal cost is 14, marginal revenue is 14, marginal profit is 0. So it suggests that 4, in fact, sorry, I've skipped forward. 4, in fact, is the profit maximizing level of output, because marginal revenue equals marginal cost. So it could be somewhere before it, but the chances are it's 4. 4 is the marginal revenue equals marginal cost. That is profit maximization. So it's in fact unlikely to be anywhere else other than 4. Let's look at this table. This is the one we've just had. Now, if we look at the profit function here, look at how profits operate. Profits rise from 15 to 26 to 32, 32, 25 to 8. And we have 3 to 4, which is at 32. So if the profit maximizing was in between, then the diagram below would show it to be somewhere in here. In fact, we've now proven that it's at 4. So this diagram, the maximum point should be here. So this diagram, which typically would be drawn with tables to show that the profit maximizing level is somewhere between certain levels of output, in this case we can identify it uniquely to be at 4, and we would have to change this diagram so that the maximum occurs at this point here, just here on that point. So that would be the maximum profit. And typically we draw profit functions of that shape. Now, average costs tend to be U-shaped. The reason for that is because of the law of diminishing returns. So as output increases, average costs tend to be high, and then they start to fall off, and then they start to rise again. They reach a minimum, and then they start to increase. And that's typically the performance or the shape of average costs as output changes. As I said, the U shape is given to us by the law of diminishing returns. And remember, here cost can be explicit or implicit, and a normal profit is also a cost. A normal profit is something that the business must make if it's going to continue in existence. Now, if we insert the marginal cost onto our diagram, the marginal cost cuts the average cost at its minimum point. The marginal cost is the cost of each unit produced, and it cuts the average cost at its minimum point. Now, average revenue, which is just really the price, that's downward sloping. So average revenue, let's say, is downward sloping. In other words, as we decrease the price, we get more sales, which is like a demand curve. And the marginal revenue will have twice the gradient of the average revenue if the average revenue is a straight line. Marginal revenue will have twice its gradient. It'll also be a straight line. And that's the relationship that we generally see in textbooks when we start to think about what's known as the theory of the firm. So we have average costs, marginal cost cutting the minimum point of the average cost, downward sloping average revenue, marginal revenue twice the gradient. And there are proofs for these which I will produce in other videos and for other modules as well. But we can see here that marginal revenue equals marginal cost at this point, at the point where output is Q1. That's the profit maximizing level of output. So we now know that marginal revenue equals marginal cost for profit maximization. So the total cost, therefore, of Q1 is the average times the quantity, which is the area of the rectangle, the bluish rectangle in the diagram. And the total revenue is the bigger rectangle, the greenish, sort of light green color rectangle, which touches the average revenue. So it's average revenue times quantity, which is just a total. So now we can see what the costs are, and we can see what the revenue is. If we subtract the costs from the revenue, we get profits. In this case, we get abnormal profits, because normal profits are built into the cost curve. The average cost curve includes normal profit, which may sound complicated. Normal profit is a cost. It doesn't sound right. Well, the reason behind that is normal profits must be made for the business to stay in existence. And insofar as they must be made, the company must make normal profits. If they don't, they'll go out of business. So normal profits can be treated as a cost. It must be covered. Now, in this diagram here, we get more than normal profits. You can see that the light green colored rectangle exceeds the average cost curve. At Q1, it's bigger. So we have abnormal profits there. The abnormal profits is equal to that area. Now, abnormal profits, what it would do is signal other producers that there are abnormal profits in this particular business. They will come in to set up against it. If there are no barriers to entry, they will set up producing similar products and try to compete away those profits. In other words, they want a share of the abnormal profits. It's a very profitable business to be in. So abnormal profits act as a signal for new companies to enter the market. So those are the excess or normal profits. Now, as I said, I'm going to go through all of this in much more detail and much more straightforwardly in other videos. So we're just going to introduce this topic here now to show how the theory of the firm fits in to our understanding of competition. But why should a company maximize profits? Well, if the entrepreneur is the owner and manager, then maximizing profits will maximize income. So if it's a small company and there's only perhaps one person at the top, the entrepreneur or the manager or the owner, that person may want to maximize profits, because maximizing income is maximizing profits. Subtracting costs and so on, the chances are maximizing income leads to maximizing profits. So at least there's more incentive, maybe a better way of putting it, for entrepreneurs and managers. If single people at the top, more opportunity for them to maximize profits, and they may be more interested in maximizing profits. Of course, it may also be the case that profit maximization may be forced on an entrepreneur by competitive pressure. If there are other companies in similar line of production, then the competitive pressure may have forced them into maximizing profits just to survive. They can't be inefficient. If they're inefficient and there's competitive pressure, they may go bankrupt, they may go out of business. Why profit maximize in non-competitive markets? Well, let's say the company is a monopolist. The company is the only one producing the particular product. Then why should they profit maximize? Well, in truth, there's no necessity for them to do so. If they're the only producer and they've got a monopoly position, they can charge a price in the market and sell what they want. There's no real pressure on them to profit maximize. Also, the separation of ownership from control means that managers could steer the firm away from profit maximization in pursuit of their own interests. Large companies are really run by the managers, and the managers have a different agenda to the owners. The owners want security of investment, they want high profit rates and good dividends on their shares and reinvestment and so on. But the managers, they want high salaries, they want good pensions, they want good working conditions, they want good holidays, they want perks, they want company cars and so on. So the managers want something different. And given that the managers run the business, the chances are companies will not profit maximize, because the managers are attempting to do something else. Finally, studies suggest that businessmen did not use marginalist rules because of uncertainty surrounding decision making, rules of thumb rather than marginal techniques in setting price. It's very unlikely that entrepreneurs and business people use marginal analysis. For a start, they don't know what the marginal cost is for many items they produce. They can't calculate it. How much does that particular item cost? And how much does it vary compared to the previous item? Well, that information is very difficult to calculate. So most companies don't know what their marginal costs are, so therefore they can't profit maximize. And also they can't continually adjust the price in the market to try and work out maximum profits, because it'll alienate customers if the prices are changing frequently. So instead of doing that, the business people work out what they think it costs to make the product, and they'll add on a markup. They'll add on 50% or 100% and try and sell the product. Depending on how competitive the market is, that will determine the markup. So it's unlikely that profit maximizing behavior will be seen in practice. And that, of course, leaves one last question to be answered. If it's not used in practice, why have we got it? Why do we even mention profit maximization if it's not used widely, or if it's not used at all? Well, the answer seems to be that we need a standard, an efficiency standard. At least in theory, we need an efficiency standard. We need to be able to compare behavior through some sort of efficiency standard to see how efficient businesses are. And also, it can be used to help governments and help agencies to try to work out what the best policy towards business is. It's not that companies profit maximize or should profit maximize. It's simply a standard through which we can think about company efficiency. So it doesn't necessarily apply in practice, but it is a model. It's an idea that can be used when we think about businesses. As I said, there are going to be more videos on this illustrating how the theory of the firm is built up and why the average cost curve is U-shaped and why the marginal cost cuts its minimum point and all of the points mentioned about the previous diagrams. So there will be much more material coming out, more videos coming out later. But for the moment, that's all we're going to deal with. Just some ideas about profit maximizing behavior and some introduction to how it works. So let's leave it at that and say thank you for watching.